Okay, so whiplash is something I've never, ever been introduced by. Normally when people talk about linguistics, they think about good grammar, bad grammar, that sort of thing, or maybe translation. I'd say a more accurate example of what I do is making stuff up. And I'm going to give you an example of making stuff up this afternoon. So I'm going to talk about language as a window on prehistory, so how we can use language to find out about stuff that we don't know anything about. So to do that, imagine for a moment that there was no information about New England's history before the year 2000. So no archaeology, no historical records, nothing like that. Even without that information, we would still be able to reconstruct a great deal about the early settlement of this area because we can use the clues that language gives us. We could work out where the main settlers came from by their place names, for example. So New London is a good giveaway for that, New Bedford, et cetera, et cetera. We could also deduce something of the settlers' interactions with Native Americans. The fact that English borrowed some terms speaks to some level of interaction, but the fact that these terms are flora and fauna terms like skunk and muskrat and so on, and technical terms like sachem, but the fact that the borrowings are mostly confined to those areas tells us that the interaction wasn't sustained and it wasn't very deep. I want to use another example I want to talk about another example for this tonight. Of course, for New England, we know a great deal about the history. We can pretend that we don't know anything about it, but of course we do have a huge amount of written material about it. But for many areas of the world, we don't have a good archaeological record. We might know that people were in a particular place, but not who they were or what they did. The archaeological or genetic record might be very patchy. And Tasmania is one such place. This is an area where language can give us clues that archaeology, anthropology, and genetics cannot, because that record has disappeared now. Aboriginal Tasmanians hold a really important place in anthropology as well, in part because of the apparent simplicity of their material culture. They seem to have had a fairly severe population decline around 8,000 years ago, and as part of that population decline, they lost a lot of technology that we would think is really basic, like fish hooks and needles and things like that. So clearly we want to know a lot more about this society and how they adapted to change. The standard story in archaeology is that there was a bottleneck following the decrease in population, and following that, the population expanded again. If that's true, that should leave clues in the linguistic record. We should be able to see that the attested languages of Tasmania might descend from a single language. So that the language cues are going to be vital here. Unfortunately, the linguistic record looks a bit like this. It's pretty difficult to use. The archaeological record is worse, but the linguistic record is pretty hard to work with as well. There's about 10,000 words total of Tasmanian languages and 44 vocabularies or word lists. They were recorded over a period of about 60 years between 1777 and 1847 by a whole bunch of different people: explorers, missionaries, convicts, priests, government officials. The last fluent speakers were dead by the end of the 19th century, though, so there's no possibility of gaining any further materials. We need to make the best of what we have, and what we have is stuff like this. So the problem here is that we need to figure out how many distinct languages are represented in those sources. So we know something about the locations of the word lists, but we don't know anything much about the language names. So Tasmanians didn't name their languages like many non-Western societies. So we can't just use a piece of paper that says, here's our list, here's our list of words, this is from language X, language Y, etc., and use that information to count up how many languages there are. We have to figure it out from the vocabularies themselves. So that should be simple, right? We should just be able to group together the vocabularies that contain the same items. But we can't do that because it's not as simple as just working out what's the same and what's different. So the spelling in the lists is so haphazard that it's hard to tell what's the same and what's different. So to take an example here, we've got a number of different words for water. We've got something that we could work out as something like ligana, likana, liana, and a whole bunch of spellings along those lines as well. Now, it's pretty easy to say that kawi, the word up the top, and likana are different words, but likana, ligana, liana, li, are they the same? Are they different? It's not so clear here. So we could think of the problem like this. We've got a large bag of balls which have different colours on them, and we need to sort out we need to sort the balls into different bins. But we don't know how many colours there are in the bag. We don't know how many different colours there are. We don't know whether some balls might have more than one colour on them. And we don't know how many bins we need either. So we don't know whether we could group together the dark blue and the light blue balls into a single bin, or whether we should keep them separate. So our solution here is to use cluster analysis techniques, particularly techniques from biology. So I guess this is one of the ways in which this talk is a bridge between the medical side and biological side and the more social sciencey and humanities side. So we can take advantage of similar properties of genes and languages to use the techniques that have been developed for biology and further refine them for linguistics. And so that's what we're going to do here. So we do that. I used a program called an algorithm called Structure, which basically solves our ball counting problem for us. It infers the characteristics of our word lists here at the same time that we're trying to work out how many different word lists, how many languages, how many different populations are represented in our sample. So on this slide, you can see some results. So each of the lines in this table is a different vocabulary, and the colours represent the bins that we want to group the word list into, the bins that the algorithm returned. And you can see that there's a fair amount of structure here in the lists. We can also see that there's potentially problematic word lists. So one of the problems that I didn't mention before about just grouping together lists that look the same is that some of the lists might have words from more than one language represented. Given the circumstances of recording, especially for the word lists recorded towards the end of our period of speech, that's certainly the case. We can also see that there's a fair amount of geographic structure to the word list. So while there are some lists that clearly contain material from more than one group, we can also see that where we have geographic information about where the word lists were spoken or where the speakers were recorded from, that also makes sense. I see some of my colours haven't worked out quite well, so this blue is the same as this purple here. And so all of the balls schmalls. All of the lists from the Oyster Bay region, this yellow region here, grouped together in here. We see some difficulty in the Western languages, between a Western group down here and a Northern group up here. And we also see that the lists with unknown geographical designations actually come from a number of different areas, from both the northeastern and western and the northern. And in fact, one of the unknown word lists has a sizable southeastern component as well. So next thing we need to think about is whether these clusters are distinct languages or different families. So if we think back to our archaeological problem of how many languages are represented in the data, if we want to draw some conclusions about how long in the past these languages were a single language, if they were, then we need to know the degree of difference between the languages. And so to test this, we can estimate the language trees from the vocabulary lists. And this lets us visualize the degree of relationship between the groups. And so we did that in a couple of different ways here. I can give you more information from my website if that's of interest. But here you can see that there's a fair amount of solid evidence for grouping together word lists at a low level. But once we go further back in the past, there's some support for grouping together Oyster Bay and Southeastern, and some support for the Northern and Western groups. But further relations are impossible to recover. So if these languages were once related, then we can't show it from the materials here. Now, I mentioned the population bottleneck from around 8,000 years ago. 8,000 years is within the realm of our methods. It's within the scope of our methods. So if these languages were related through a population bottleneck, we should be able to show that. So in conclusion, archaeologists and anthropologists have assumed a single language community for Aboriginal Australia, for Aboriginal Tasmania, but the language records, even though they're pretty fragmentary, they tell a very different story. So language salts away clues to the past histories of their speakers. And because they change in regular and systematic ways, we can use the information from currently attested languages to undo the changes and reconstruct otherwise unrecorded history. And so this is one of the many ways in which we can make the past come alive for language, and that's one of the things I find really, really cool and really inspiring about linguistic work, the way it goes into so many different areas, not just the language and not just grammar. So thanks very much.